Okay, we're going to continue to work with quadratics in this video. We're not going to be making graphs, but what we're going to do is convert from the general form of the quadratic to the vertex form of the quadratic, and we're going to employ a technique called completing the square. A little more specifically, we're going to go from the general form here, which is y equals ax squared plus bx plus c, to vertex form, which is y equals a times a quantity x minus h squared plus k. Now there's some steps here that I'm going to try to refer back and forth to as I do the example on the next slide. Okay? They are: group the ax squared and the bx terms in parentheses, is step 1. Then we're going to do step 2, which is factor out a. Now you're not going to need to do this if a is 1. Okay, so you kind of can skip this. If a is not 1, the problem is more complex a little bit later, which tends to make sense. When a is not 1, we've seen that making problems more complex when we factor. It's going to be more complex here too. Okay? Divide the coefficient of the linear term in half and square it. And you do this mentally. Okay, just kind of hold it in your head, or you can do it off in the margin. And then 4, you're going to add the result and subtract the result to the expression. Now there you're going to have to be very careful that when you add the result, you are noting exactly what you are adding. It might not be obvious. That has to do when a is not 1. Okay, you may have seen that before when we did ellipses and circles, when we did complete the square there. So maybe that'll refresh your memory when we do it again here. And step 5 is group the perfect square trinomial, which is what you've created by steps 1 through 4. And then factor the perfect square trinomial into a quantity squared. And by then, you should really see this form of an equation take shape. Okay? So, let's move on to an example here, okay, where we're going to convert to vertex form. Here we see that we are, in fact, given general form, okay? And we're going to try and move it into something that looks more like this. Again, these will be equivalent expressions, so they'll be the same exact equation. If you graph both of them, you should get the exact same graph. That's how you can check it in the end. Okay, so the first thing we're going to do here is look at our steps, and we're going to group the ax squared and bx terms in parentheses, okay? So let's see what that looks like. We're going to group the ax squared and bx term in parentheses. Okay? Step 2, is to factor out a, skip if a is 1. Okay, well, a is 2 here, so we're going to factor out that 2. And this is what we're going to get. We're going to get y equals 2 times the quantity, x squared minus 6x, and I'll just bring down the plus 1. Okay? So then we're going to take a look at divide the coefficient of the linear term in half and square it. Do this mentally. So our linear term here is this negative 6. Linear means it's with the x term, not the x squared term. Okay? That's a vocab you guys should be familiar with. So I'm going to cut that in half. I'll do it up here in the margin and get negative 3. And then it says to square it. So that's going to give me 9. Okay? So add the result and subtract the result to the expression. Okay, well, if I add it and subtract it, it means I've really kind of done nothing. Well, I've done something, but I won't change the expression's value. Okay, so let's actually see here. Again, wrong slide. Again, there was this 9. So I'm going to add it and subtract it. So let's see what that looks like. It's a little tricky, actually. Y equals 2 times x squared minus 6x plus 9 plus 1. Okay, now if you see, I've added 9. But if you look carefully, I haven't really added 9. I've added 2 times 9, which is 18. So for me to subtract the result that I actually added, I don't subtract 9. I actually am going to subtract 18. Again, because when I added the 9, it was 2 times 9 because I factored out the 2. And then that would be 18. So now I'm subtracting 18. So this is really a net effect of nothing. Okay, well, if you're sitting there saying you haven't really done anything, why'd you bother to do it? It has to do with this expression I've created right here. That's a very special expression. It's a perfect square trinomial. And if you notice here, my next step says to group the perfect square trinomial. And I have here, it's in parentheses. And then I'm going to factor the perfect square trinomial. So perfect square trinomials just factor into the difference or sum of their square roots. So this green thing I have underlined here factors into x minus 3 squared. Then I'm going to clean up this part of the expression here, which is 1 minus 18, which is negative 17. Now, if you notice, this is now of the form y equals a times quantity x minus h squared plus k. Okay? So I've converted the form from general to vertex. I use a technique called complete the square. And that is what I did by taking these 2 terms and adding a third term of 9 to make perfect square trinomial. Why? So I could factor it into this. That was the trick that allowed me to write that square of a quantity, which you notice is what we see in the vertex form. So watch this over again. It's a little tricky, but read the steps, pause, go through it, just try and concentrate. It really is all right there. Enjoy.